In this video, we're going to look at reciprocal trigonometric ratios, which, that's a pretty scary sounding name. You've actually seen them a bit if you remember your graphing techniques. We did graphing a couple of these, but, we can use them just as well doing pretty normal trig stuff with them. So with the reciprocal trig functions, they have somewhat confusing names. The reciprocal of sine, so 1 over sine, we call cosecant or cosecant, as Americans would say, or just we write it as CSC for short, kind of like how we write sine as sin. And perhaps confusingly, cosine's reciprocal, 1 on cos theta, is just called sec or secant. So, you might notice the cos have swapped. Now, how do I remember that? The way I remember it is that they don't make sense. That, surely it makes more sense that sine would go with sec, but not so. So I remember that it doesn't make sense, so I remember that the reciprocal of sine is cosec, and the reciprocal of cos is just sec. The one that does make sense is the reciprocal of tangent is just called cotangent. How simple, how obvious. So that gets called cot. We write it just cot theta as 1 on tan theta. So not so bad, just some names for things. Let's have a go at how you might use them. My tip is just really kind of sub it into the formula we've got over here. And, it becomes pretty straightforward, relatively quickly. I'm just going to move on to the next slide where this tip disappears, so I've got a bit more space. If you want to read it, just pause the video. So let's just do it. So cosec, remembering that it doesn't really make sense. So cosec is actually 1 on sine. So we're saying this is the same as 1 on sine of pi on 4. Pi on 4. So remember that we can use our special triangles. One of them is this, 1, 1, root 2. And pi on 4 are 45 degrees in each corner. Except for that one. So sine of pi on 4 is 1 on root 2. So we've got 1 on root 2. An easy way to deal with this is, well, that's the same as 1 divided by 1 on root 2, agreed? Yeah. And then we just do our stay change flip. So 1 times root 2 on 1. So this is just root 2. So cosec of pi on 4 is root 2. Fair enough. That was fairly quick, so feel free to go back if you need to say that a bit slower. Now, all right, so sec. Sec is 1 on cos. So we're doing sec of 2 pi on 3 is the same as 1 on cos of 2 pi on 3. So now that we've got that, we're going to have to work out 2 pi on 3, and we'll just put it into this reciprocal here. So 2 pi on 3, where are we? Draw it up here. 2 pi on 3, it's out there. 2 pi on 3, and the angle with the x is pi on 3. And we're in the S quadrant. The second quadrant is just sine is positive, so this is going to be negative. So this is going to be the same as 1 on negative cos of pi on 3. Yeah? We're going to need our other triangle for this. Where should we draw it? Maybe up here. Our other triangle looks like this. This is 2, this is 1, this is root 3. This is pi on 3. And up there's pi on 6. So, cos adjacent over hypotenuse, right? So it's 1 on 2. So we've got 1 over negative 1 on 2. Again, if you struggle with this kind of thing, just do the 1 divided by negative 1 on 2. So it's just 1 times minus 1 on 2. So it's, the reciprocal of that. So it's 1 times minus 2 on 1. So it's just minus 2. Not so bad. All right. Final example, we've got cot of 7 pi on 6. So it's just 1 on tan of 7 pi on 6. So we're going to have to draw ourselves where that ends up, 7 pi on 6. So all the way to there is pi, which is 6 pi on 6, right? So 7 pi on 6 is there, where this is pi on 6, yeah? So we are in the AST quadrant. So this is still going to be positive. So this is the same as 1 on tan of pi on 6. And over we go to our little drawing here, where up here is pi on 6. So tan is opposite over adjacent, 1 on root 3. So it's really just, if you think about it, that's the same as tan of pi on 6 to the negative 1. Like we just say that as the reciprocal of tan of pi on 6. So it's the reciprocal of 1 on root 3 if you think about that, that is just root 3. Which, that's another way to deal with those. So there we have it, how we deal with our reciprocal